In this class, I will discuss two problems on support reactions. So, the first problem is an examination problem, January 2021. This is the diagram given. So, it says simply supported beam with a overhang portion. So, this B is the overhang portion. So, you have two reactions here, RA and RB. A and B are the simple supports. The question here is, we have determined the distance, this x, distance x from the support B to the point E, where the 10 kN is acting, so that the reactions are equal. So here we have given both the reactions RA and RB are equal, and using that condition we have to find the distance x here. So as you know, you have two reactions in a simply supported beam, but here the reactions are equally as given, therefore it reduces to one unknown, and x is another unknown. So two unknowns will be there, and you have to use two equilibrium equations to solve for the unknowns. So the equilibrium equations are sigma Fy is 0 and sigma m 0. Let me take sigma Fy is equal to 0 first. Forces acting upwards, positive, downward, negative. RA and RB are acting upwards, then all the other forces are acting downwards. So minus 10 into 2 is the total UDL. Minus because it is acting downwards. Minus 30, minus 20, minus 10 is equal to 0. Since here RA is equal to RB, you can just replace this RB by RA. So RA plus RA becomes 2RA is equal to 20 plus 30 is 50. 50 plus 30 is 80. So RA will be 40. You can see that here RA will be equal to 40 kN. So this is also equal to RB. So both the reactions are equal. Now using the moment equation, second equation is, you can take the moment about A is equal to 0 and the moment about B is equal to 0. I will take sigma MB is equal to 0. Clockwise I will take positive, anti-clockwise negative. So if I want to take the moment about B of all these forces and including reaction, this RA is equal to clockwise moment about B. So plus RA into distance from B is 7 meters. So RA into 7. It is clockwise, therefore positive. Then this 10 kN per meter UDL will be acting at the midpoint. So it is 10 into 2, 20 kN will be acting at the midpoint. That is how we have to take the equivalent concentrated load. It is acting at midpoint. The distance from B will be 4 plus 1 plus 1. So it will be 6. So 10 into 2, 20 kN will be acting at a distance of 6 meters from B, and the moment due to that is anti-clockwise, minus 20 into 6. Then you have the moment due to this 30 kN is also anti-clockwise. 30 into 5, distance is 5, minus 30 into 5. Then moment due to this 20 kN is also anti-clockwise, minus 20 into 4 meters. Moment due to this RB will not be there because it passes through B. Moment due to 10 kN is positive, therefore plus 10 into distance is x. Now please note that x is the unknown here, and this is equal to 0. Now you can substitute the value of RA as 40 kN. We have got in the first step. So 40 into 7 minus 120 minus 150 minus 80 is equal to 10x. I have got to that side because plus. Therefore 10x is equal to 280. If this goes to that side, it becomes negative, minus 280. And of course this is 270 plus 80 is 350, which becomes 70. So therefore x is equal to 70 divided by 10, 7 meters. So suppose if the distance x is 7 meters, then these two reactions will be equal. So that is the concept here. The simple problem carrying 8 marks in the examination. Now I will take up one more problem from the examination question paper. The problem runs like this. Here he has given this is the problem of March 2022 VDU question paper. It runs like this. He has given a beam like this. So it is inked at this end, and it is roller, but it is inclined roller at the other end. You can see here this is an inclined roller, so that the reaction is normal to this. This is your RB. If I take this as B, this as A, that is RB, and the angle he has given, this angle he has given 30 degrees. 30 degrees. This beam is subjected to a clockwise couple of 900 Newton meter at the point C, and UDM runs from here from D to B, and intensity of UDM is W, which is not known, per unit length. The W per unit length. The distance is being from A to C, it is 1.5 meter. From C to D is also 1.5 meter, and this is 3 meters. These are the distances. Now this is a hinge end. So naturally we know that at the hinge end you will be having two reactions, HA and VA in general. And at the roller end you have only one reaction, which is normal to the plane of the roller, which is like this, which is making an angle of 30 degrees. This roller is making an angle of 30 degrees with the horizontal. Therefore, this angle will become 60 degrees. Please note that 90 minus 30. That means RB is making an angle of 60 degrees with horizontal. The meaning of that is, if you resolve that RB into two components, RB cos theta and RB sin theta, your RB cos theta will be like this, that is cos 60, and RB sin theta will be like this. This is RB sin 60. So these are the components of this reaction RB along the global x and y directions. Now this is the thing. Now the question here is, find the intensity of uniformly distributed load. That means W we have to find out. So find the intensity of uniformly distributed load such that the vertical component of reaction at A is 0. Vertical component of at A is equal to 0 means VA should be 0. So this is given. So by taking VA is equal to 0, we have to find out the value of W, and also find the reactions at both the supports. So also we have to find out the reactions. Once VA is 0, only we will be having HA, and we have to find out RB. So HA and RB we have to find out. VA is given as 0 in this problem. By using the condition VA is equal to 0, we have to find out the WN, so intensity of WN. So now, so here this becomes 0. So according to the given condition, VA is 0. Now let me write the free body diagram of the beam. The FBD of beam. So FBD of beam runs like this. This is beam is AB. So you have only horizontal reaction at A. He has given vertical reaction at A as 0. Only take HA, and you have this C. You have a clockwise couple given, external couple given, 900 Newton meter. It is given in the problem, and of course this UDL can be converted into a concentrated load of total load of W into 3. The intensity multiplied by the length is the total concentrated load, which acts as the midpoint. So I will take the midpoint as E here. So E here. So the distances are like this. Distances you should write very correctly because we have to take the moments. So from A to C it is 1.5 meter. From C to D it is 1.5 meter. D to E it is also 1.5, midpoint of 3 meter. So everything is 1.5 meter here. Now this UDL I will convert down to concentrated load acting at E. W into 3, so 3W. So that is the concentrated load which will be acting at E. 3 into W. Please note that W is in kilonewton per meter. That is the intensity. Whatever value of W you are going to get, it will be in kilonewton per meter. Now this RB I will write in terms of components. I will write RB cos 60 is the horizontal component. RB sin 60 is the vertical component. Now this is the free body diagram. So it is the diagram which shows the reactions removing the supports and also the external forces acting on the beam. Now here you can observe here is there are two unknowns HA and RB because VA is 0 he has given. Using two equilibrium equations we can find out the reactions now. So So only RB and HA they are the unknowns. Now what I will do here is I will take sigma MB is equal to 0, or you can take sigma MA is equal to 0. Okay, sigma MA is equal to 0. Clockwise moment positive, anti-clockwise negative. I am taking the arbitrary sum of the moments of all the forces about this point A and taking clockwise as 0. Now what happens here, this is a clockwise couple given, you can directly write that you need not multiply by the distance, where it acts the value of the effect of the moment remains the same, and this 3 into W is also giving a clockwise moment. So 3 into W is the force into distance from point A, it is 1.5 plus 1.5 plus 1.5, so that is 4.5. 4.5. So this is the moment due to this 3W. And this RB cos 60, it is not giving any moment because it passes through point A. This RB sin 60 is giving an anti-clockwise moment. So minus RB sin 60 into distance from the point A to this RB sin 60 is total, that is 6 meters, is equal to 0. So this is the equation we get using moment equation. So it becomes 900 plus 4.5 into 3 is I think 13.5 times W minus sin 60 into 6 into RB. So it is, the value will be now, I can take this as 6 into sin 60 is equal to 5.196 RB is equal to 0. We cannot solve this because there are two unknowns. All this has equation 1. Now the second equilibrium equation here that we can use is sigma Fy is equal to 0. Sigma Fy is equal to 0 if I use, see, upward positive, downward negative. If I take, now here what happens, if I take this, only one reaction is there in the vertical direction, RB sin 60, that is positive upwards. So this is negative, minus 3 times W is equal to 0. This won't come into picture when you are writing force equation. Moment you should not consider. So this is the another equation. So from this you will get RB of 3W is equal to RB sin 60, RB sin 60, or you can take W is equal, or you can take RB is equal to 3W divided by sin 60, which comes out to be 3 divided by sin 60 is equal to 3.464. 3.464 times W. So this is the relation between RB and W. Now you can put this relation in this equation and you can solve for W, because it will reduce to one unknown. Substituting for RB in equation 1. So the thing is 900 plus 13.5 into W is 13.5 W will keep it as it is, minus 5.196 into RB is 3.464 times W is equal to 0. Now you can simplify this to get the value of W. So 13.5 is that, minus of 5.196 into 3.464, it comes out to be minus, so 900 minus 4.4989. 4989 is equal W is equal to 0. Therefore, from this W will be equal to 900 divided by 4.4989. It comes out to be 200. 200 point, can take it as 200. It will be in kilonewton Newton per meter, because the moment here given in Newton meter, it is 200 Newton per meter. So this is the value of W, and once you get the value of W, you can find out the reaction RB. RB is 3.464 times W, which comes out to be this multiplied by W, 3.464 into 200, which is 692.8 Newton. So that is the reaction at B, and reaction at A you can find out using the third equilibrium equation, which is sigma Fx is equal to 0, treating right side forces acting positive. So here HA is positive, RB cos 60 is negative. Only two forces are there. HA minus RB cos 60 is equal to 0, or HA is equal to RB cos 60. So RB is 692.8. So 692.8 multiplied into cos 60 is half, of course, 0.5. So 346.2 Newton. The answer will be Newton. So this is the reaction at A. So we are getting positive value, that means the assumed direction of it is correct. Here also RB is positive, that means whatever direction you have assumed for RB, like this, that is correct. So this is how we had to solve the problem when unknown force is unknown. So some condition they will give to solve for the unknown. Of course here HA, RB, they are the unknowns. So you can easily find out and W, HA, RB, W, three unknowns are there. So I have used all the three equilibrium equations, sigma Fx0, sigma Fy0, sigma Ma0, so to solve for the three unknowns.